minus square root a squared minus 4ac all over 2a.
Well, welcome back. No, that was not me singing, but I did want to remind you of the quadratic formula song, and hopefully you all heard something similar to that during your class when we taught it to you. So let me just recall, that is x equals, don't forget that important part, negative b plus or minus the square root of b squared minus 4ac divided by 2a. So a couple things to stress. Notice that this whole thing here is over my 2a, not the equal sign, of course. And when we substitute these in, I just want to remind you that this should be in parentheses, your a value and your c value should be in parentheses on your calculator. Now, where do you get those a, b, and c terms? Well, just real quickly, it should be ax squared plus bx plus c equals 0. So a is the coefficient of x squared, b is the coefficient of x, and your c term is all alone. All right, so let me just start by saying that this is 100% calculator work. We're going to do a lot of storing. So please go get your calculator, pause it, you've got to have it with you. I'm only going to do 3 problems. These take a while because, again, it's a lot of storing. So number 1, find theta to the nearest degree. So that's the first thing I got to watch, nearest degree, so I know I'm going to have to round and use my calculator. 2 cosine squared theta minus 4 cos theta minus 5 equals 0. And their interval they give me is 0 to 360. Now remember, brackets mean include. So you can, whoops, I'm not spelling include right. You can include 0 and you can include 360. And lastly, before we dive in, I just want to be careful on how we read this. This actually here says cosine squared theta. Read it in the order you see it. You see cosine, then you see a squared, then you see theta. Cosine squared theta. Okay. So my equation set equal to 0. Now you could try to factor, but we already told you it's quadratic formula day, so let's set up our quadratic formula. So I'm going to start with x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now you'll notice I don't even have an x in this problem, so I don't want to say x equals. What trig function are we solving for? Well, if you look, the only trig function is cos theta. So we're actually going to start this with cos theta equals. Okay, here's my a, my b, and my c. So negative b is going to be positive 4 plus or minus the square root, parentheses are a must. Negative 4 squared minus 4 times 2 times negative 5 divided by 2a you can do in your head. 2 times 2 should just be 4. Okay, you should know the drill at this point. We're just going to clean up what's underneath the radical. Don't type the radical in itself. Just the junk under. Grab your calculator, go for it, pause it, and see what you get. I've got a 56, and hopefully you agree with that. Now, here's where it gets fancy. At this point, a lot of people, we typically, when we have to leave it in simplest radical form, we'll break our radical down. We're not going to do that at all because they said nearest degree. All we're going to do is split up our 2 terms. Now, you might be saying, why are there 2 terms? Well, I hope you know why. You have a plus and a minus. So my 2 equations are going to be cosine theta equals 4 plus radical 56 over 4 and cosine theta equals 4 minus radical 56 over 4. Okay, so I'm just going to focus on the one on the left first and then we'll attack the one on the right. And like I said, this is a lot of storing, so stay with me. Okay, we're going to simply type this junk in the calculator. Now let me give you 2 tips. If you have that updated calculator, if you hit your second y equals button, you get that fraction tool. If you have the old calculator, no updates, you're typing in 4 plus radical 56. You are hitting enter next. Then do divided by 4. So choose whichever one you have and let's go for it. Now, what do you need to see on paper? We have to see that cosine theta equals, and you have to write that number down. So I've got 2.8708286. And I'm going to hit store into alpha A. Okay, and then I'm hitting store into alpha A on my calculator, and I'm going to rewrite this as cosine theta equals A. Okay, these 2 steps we've got to see. You have to tell whoever's grading your paper what number you're storing into alpha A. Okay, now, to solve for theta, we're just going to take the inverse cosine, just like we've been doing, of alpha A. Hopefully you get an error on your screen. And I just want to talk about why maybe and hopefully you can catch this in the future yourself. Since we're talking about cosine, I'm going to draw my 4 tick marks and sketch cosine as quick as I can. It starts at 1, 0, negative 1, 0, 1. Okay, and I'm sure you know that by now. Oops, I missed that point. The question is, does cosine ever hit 2.870? Well, if I look at my graph, if that's 1, that's 2, I would say 2.870 is about up here. Would you say that graph ever hits 2.870? Heck no, the graph only goes to a height of 1. So here's the deal. Any number that you see above 1, you should get an error on. And I think it makes logical sense. The graph just doesn't go that high. How about any number less than negative 1? Could the cosine graph ever hit a number under negative 1? No. So you would get an error then too. So maybe there's a quicker way. If you ever see this number greater than 1 or smaller than negative 1, you know right off the bat you're going to get an error. Which means on this side there are just no solutions. All right, let's go do the same thing on the other side. Type this bear in your calculator. We're going to store it into alpha B. Take your time, make sure you can type it in correctly. This time I've got negative 0.8708286 storing into alpha B. So I can say cosine theta equals B. Again, you have to show the grader what you're putting in your calculator. Now, here's where all the storing comes in. Can the cosine graph, let's determine if we're going to have an error or not. Can the cosine graph hit negative 0.8? Well, I would definitely say yes. Anything between negative 1 and positive 1, the cosine graph can reach, and that certainly is between there. So I know I'm going to have some answers here. Let's talk quadrants. Okay, we'll do an all students tip cows. I'm cosine, and am I positive or negative? Well, B is a negative number, so I need to be where cosine's negative. So I'm not in all, and I'm not in cosine. So I should have two answers, one in quadrant 2, one in quadrant 3. Okay, we're getting closer. Now, you're not going to inverse cosine if it's a negative. The negative told you what quadrants you're in. So I want you to, on your screen, you're going to hit times negative 1. All right, and why am I doing this? Well, I want my value to be positive. I don't want to inverse a negative number. So I'm hitting times negative 1, and I'm restoring that number into B. So restore into B. Let me say it again. I need my B value to be positive. The negative just told me where my quadrants are. So I'm taking my B value, I'm hitting times negative 1. Now it should be a positive number, and I'm going to restore that into B. Now I will inverse cosine both sides. Okay, now here's the next deal. You get this ugly decimal, 29.4449, etc. This does not answer your question. Okay, you can't call this 29 degrees. It doesn't work that way. Store this answer into C. Okay, so I told you in the beginning there's a lot of storing. Store this answer into C. All right, let's go get our two answers now. In quadrant 2, okay, here's my reference angle in quadrant 2. I need that whole angle. So I'm going to take 180 minus that ugly decimal that I stored into angle C. This answer is my final answer, so I can round this. I get 151 degrees. In quadrant 3, here's my reference angle. To get the whole thing, I'm going to say that's 180 plus angle C. Okay, rounding this answer to the nearest degree gets me 209 degrees. So my final two answers in my bracket notation are 151 degrees and 209 degrees. And the other one, of course, was a no solution. But I think you can get an appreciation for what I mean by a lot of storing. Okay, so take your time. We're going to do a total of 3 problems together. We've got one under our belt, and let's try the next one. All right, question 2. Find x to the nearest degree. So this is my hint that we're going to have to, use our calculator. I've got this nice equation, 4 cos x plus 3 equals 2 over cos x, and my domain is 0 to 360. Okay, so what I'm saying to myself is I have a fractional equation. Basically, I have an equation, there's my equal sign, with a fraction in it. So, fractional equation. If it helps, you could put each of these over the number 1. Now just simply ask yourself, what's the common denominator? Well, a 1 and a cos x would be 1 cos x. So I'm going to multiply every term by cos x. Okay, 3 terms, we're writing it down 3 times. Okay, now does anything cancel in the first set of terms here? Well, certainly not. It only cancels if you have a term on the bottom and top. These terms are both on top. So cos times cos is cos squared. So I should get 4 cosine squared x. Notice the squared is on the cosine, not the x. Does this cosine cancel with anything? Nope, it's on top, so I just get plus 3 cos x. Then there's an equal sign. Now in the last term, I have a cosine on top with a cosine on the bottom. Those actually cancel. Equals 2. All right, before I go any further, I have to set my equation equal to 0. And we're off. Now, we're looking for answers to the nearest degree, so we know we're going to have to round. We're going to use our calculator, and we already know it's quadratic formula day. So I've got, instead of x equals, my trig term is cos x equals negative b, so negative 3 plus or minus the square root b squared minus 4 times a times c divided by 2a should be 8. Okay, clean up underneath the radical, that's the easy part. Think I end up with a 41. And now I'm going to split. Okay, so this is just all the old stuff, nothing too fancy at this point. Split your equation, cos x equals negative 3 plus radical 41 over 8. And we're just going to take one side at a time. So we'll slow it down and we'll start on the left-hand side first. Okay, just take all this junk, we're going to type it in our calculator, store it into alpha A. Let's see, I get 0.42539, etc. I'm storing that into alpha A. So I've got cos x equals A. Now, before I go any further, ask yourself, are you going to get an answer or an error? Does the cosine graph go up to 0.42? Well, yeah, it goes up to anything up to 1. So I know I'm going to get an answer. That means I need to get my reference angle, and I need to determine my quadrants. All right, so let's see. We're cosine and we're positive, so we can be in the all, and we can be where cosine is positive, which is the fourth. So I need an answer in the first and an answer in the fourth. All right, since I'm already positive, we'll just inverse cosine of that answer. And I get 64.8246, etc. And I'm going to store that into alpha C. Okay, it's not my final answer, so I can't round it. I'm storing that into alpha C. All right, so in quadrant 1, remember, you are your own reference angle. So to the nearest degree, I would say that's 65 degrees. Now in quadrant 4, if I draw it in, that's my reference angle. I need my whole big angle. So I would say that's 360 minus angle C. And to the nearest degree, that gets me, 295 degrees. Okay, so I've got my two answers on that side. Let's go get the other side. Take this junk, and we're going to store that into alpha B. And I've got cos x equals negative 1.175. Now, before I go further, should I get an answer or should I get an error? Well, the cosine graph, we said, goes up to a height of 1 and down to a height of negative 1. Negative 1.17 is going to fall beyond that. So it should make sense I get an error. And go ahead and inverse cosine just to prove it, but I believe you get an error. So my only two answers happen to be from this other side here. So in my bracket notation, I have 65 degrees and 295 degrees. And there you have it. Well, I've got one more for you, and it's a little ugly, so stay with me. And again, just a lot of storing. All right, solve for x to the nearest 10 minutes. Ah, ugly. We all hate those minutes, but that's what we have to pay attention to. So we're going to have to use that minute, degree, minute, second button. And here's my equation for sine squared x. Remember when you read it in order, sine squared x minus 5 sine x minus 6 equals 0. And here's the other thing to pay attention to. Notice the closed bracket on the 0, which means include, and the open bracket on the 360, which means does not include. Okay, so watch those. They try to mess with you. You're not including the parenthesis, but you are including the bracket. Okay, so if I get 0, it's an answer. If I get 360, we got to kick it out. All right, now you could factor or go quadratic formula here. It's totally up to you. Here's kind of my rule of thumb. If I try to factor 4, guess and check, right? I can either use 4 and 1 or 2 and 2. And if I try to factor 6, I've got 6 and 1 or 2 and 3. That's a lot of guessing and checking. So if I have to do too much guessing and checking, I usually go with quadratic formula instead. So that's what I'm going to choose. If you want to guess and check, go for it. Notice my trig function is sine x. So I'm going to say sine x equals. I'm going to pause it, let you fill in the quadratic formula. Let's just see if we're on the same page. So there you can see mine, and I end up with sine x equals 5 plus or minus radical 121 all over 8. Now, this one's actually kind of special, which tells me that it could have factored. What do you know about the square root of 121? That's one number you should have memorized. The square root of 121 is the number 11, so I don't need the square root. Again, it is 11. And all that tells me is that this would have factored nicely with guess and check. So I'm still going to break it up. I'm going to say sine x equals, let's say, 5 plus 11 over 8. And sine x equals 5 minus 11 over 8. All right, sine x equals, that's 16 over 8, which is, of course, 2. Can the sine graph equal 2? Before I even begin, does the sine curve go up to 2? Well, again, it goes up to 1 and down to negative 1. So if you try to inverse both sides, you should get an error. The sine curve cannot hit 2, normal sine curve. So I got no solution on that side. Next side, sine x equals negative 6 over 8, which is negative divided by 2 3/4. Okay, and I'm going to just throw that as a decimal. 3/4 is 0.75. All right, do I have an answer? Does the sine curve go down to negative 0.75? Well, of course it does, because it goes down until negative 1, so it's going to hit negative 0.75. Okay, so that means I have answers. So this is where I have to slow down. Lots of things to consider. First of all, let's get our quadrants. All students tip cows. I'm the sine graph, and I'm negative. So I can't be in all, and I can't be where sine's positive. That means my two answers should be in quadrants 3 and 4. Okay, the next thing I have to go get is my reference angle. Now again, you don't want to put the negative in. So you are taking negative 0.75 on your calculator and multiplying that by negative 1. Okay, and that's what I'm storing into alpha b. So I should have sine of x equals b, and b should be positive 0.75. I want the positive number. Remember, the negative told me the quadrants. That's what the negative does. Okay, so I'm inverse sine of 0.75. And you should get a nice ugly decimal. I've got 48.590, blah, 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 storing that into alpha c. Okay, so now, to get my third quadrant angle, here's angle C, I'm doing 180 plus angle C. Now here's the trick. You're not done at this point. The question said to round to the nearest 10 minutes. So my 180 plus C gets me 228.5903, blah, blah, blah. I have to hit that second angle. Okay, so jot it down on paper so you know where it is. Second angle. And option 4 says to convert to degree minute seconds. So I should get 228 degrees, 35 minutes, and 25.36 seconds. Now, I have to round this bear to the nearest 10 minutes. So I'm going to round my minutes. 35 minutes falls between 30 and 40 minutes, so I'm going to say this is 28 degrees. And to the nearest 10 minutes, that's going to make it 40 minutes. So notice I'm keeping the degrees, just rounding the minutes part. All right, we're going to do something similar for quadrant 4. Here's my reference angle in quadrant 4. I need that whole angle. So remember, C was my reference angle. So this time I'm doing 360 minus angle C. And I get 311.409. Okay, now I don't want that number. I need it to the nearest degree minute second. So I'm doing that second angle again, going DMS. And I get 311 degrees, 24 minutes, and 34.64 seconds. Now I've got to round this one to the nearest 10 minutes. So that 24 minutes falls between 20 and 30. And because it's at 24, I'm going to keep it down to 20 minutes. Okay, so the nearest 10 minutes. And there you have it. So my two solutions in my nice bracket notation are 228 degrees and 40 minutes, and 311 degrees, and 20 minutes. Well, we did 3 great examples tonight. Hopefully you took your time and you're ready to go tomorrow. We'll see you then. Have a great night.